All right, so we are going to learn here how to graph quadratic inequalities on our calculator. And just to be specific, these are two variable quadratic inequalities. We've already solved one variable quadratic inequalities. So when there was just an X and numbers, notice that in our examples that you see down here that we have both an X and a Y. So in order to graph them, we obviously have to have the equation solved for Y so that we can enter it into our calculator. I put a reminder here that if you're solving for Y and you have to multiply or divide by a negative number, that you have to flip the symbol. So if it was a less than and you divide by a negative, you have to make it a greater than and vice versa. So then we're going to enter the equation into the Y equals screen using our xt theta n button to enter our x's. So I'm going to go ahead and do that for our first example here on the graphing calculator. So x squared minus 6x plus 9. So here's my calculator. Go to y equals, clear out stuff I don't need. And so then x squared, and then I already forgot what it was, minus 6x. So minus 6x plus 9. I have no idea what kind of window I have right now. My y-intercept is at 9. So I'm gonna just zoom 6 it and then adjust from there. So I have a feeling I had a really big window from some word problems. But there we can see a pretty good picture. We can see the y-intercept, we can see the x-intercept, we can see the vertex, we can see the shape. So that looks pretty good. Okay, now what we need to do, because right now it's just an equation, we need to change the symbol to match the solved inequality. Now there are two different methods here. My on-screen emulator can only do choice 1. I'm going to try to switch over to my webcam and see if I can show you a calculator with choice 2. I don't know how well that's going to work, but I'm going to try. Because the emulator does not have the Inequals app. Some of your calculators aren't going to have the Inequals app. So that's why it's important to pay attention for both. Notice that I've shown you what you're looking for. So we're going to scroll to the left of whichever Y entry we're using. And for greater than or equal to's, we're going to choose this guy. For less than or equal to's, we're going to choose this guy. That means above the line, below the line, so greater, less is kind of how it goes there. So in this case, my symbol is greater than, so that means I'm going to be choosing this symbol here. So go to my y equals, scroll to the left, press enter, doesn't matter what color, but now I'm going to find the one, there we go. That looks like the shaded upper plane. I'm going to hit OK. And then I'm going to hit graph again. And so notice now that it's showing me where the shading should be, because the solution to the quadratic inequality is going to be all of the points that are in the shaded region. So our calculator is showing us the answer. The key here, though, is that we need to be able to actually plot real points exactly. So that's what I have on the rest of the notes over here. So I've already adjusted my window. I've already pressed graph. I don't need to readjust. I can see everything that I need. So first, I need to find x-intercepts by doing second trace choice 2. So if I go back here, second trace choice 2 for zeros. So left bound of the 0 just means I want an x value that's left of where it's touching the axis. So that would be that. Remember, you can also type these in instead of scrolling if you prefer. That's going to be right bound. I tell it to guess, and it's telling me, look at this, 3.00000011. this is the 0.30. The most we would round to is 2 decimal places. So this is estimating, but it is at exactly 3. The calculator just can't get it exactly right since it's estimating, but I do have just one x-intercept at 30, which also happens to be my vertex in this case. So I don't need to find a second key feature here, which is kind of nice because I've already got the vertex. Now, if you want to check your vertex, you could second trace, and then in this case we would do minimum because it opens up. But again, I know that they're the same point, so I'm not going to go over that again on this one. The y-intercept, remember, is the constant of the inequality, so you don't have to use your calculator for that one. You should just be able to look and write it down. It's at 0.9. If you want to do it in the calculator, if you press second graph, remember it gives you a whole bunch of points. You look for when x is 0, and we can see that it's 9 here. Notice that in this case, we can also see 30. If we want some other points to plot, that can help us as well. Now, when I go to actually graph it, we have to be very careful. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9 is just barely off the graph. So I'm going to go ahead on my y-axis and count by 2s. On my x-axis, I'm going to keep it by 1. So you don't need to label it if you're keeping by 1. So 2, 4, 6, 8. So 9 would be right here. On my x-axis, I have a point at 30. I know that these should have a symmetric quality. I also know, and this is the downfall to this choice 1, is that I can't distinguish between the greater than and the greater than or equal to. But because this is a strictly greater than, my boundary line should be dashed. So when I look at this, I've got 1, 4, 4, 1 would be two other pretty easy ones to plot. So 1, 2, 4, 4, 1. And I'm going to connect then a parabola shape using a dashed boundary. And the calculator has told us on the graph, and if you'd forgotten, you can look back, that the shading in this case should go on the inside. Then it says, we found and record the x-intercepts and the vertex, so I can just write and vertex here because it's both. So I did that. Now I need to list 2 ordered pairs that are solutions and 2 ordered pairs that are not. That's an L, solutions, not solutions. So solutions are going to be any ordered pair on the inside. So remember, we're counting by 2s on the y-axis, so I'm going to pick the point 2 and then 2, 4, 6. So the point 2, 6 is a solution. Then I could pick 1, 2, 3, 4, 2, 4, 6, 8, 10 would be right here. And again, you can pick anything that's in the shaded region. It's still going to be true. Not solutions. 0, 0 is not a solution. I can see that -2, -2 is not a solution. An infinite number of options there. Okay. Now I'm going to look at part B, 14x squared plus 25x plus 6. So I'm going to try to switch over. I don't know if it's going to work super well, but I'm going to try to switch over to the webcam here and see if I can show you how to use the inequals. All right, sorry, that's a no-go. It won't let me switch over in the middle of a recording. So sorry about that. We're going to have to just use this first option, which works on every calculator, by the way. So even if your calculator has this app, you can do it the way that I just taught you. If you want to use the Inequalities app, I've kind of written out the instructions here for how you could do that. So we have a new equation this time, so 14x squared. So I'm going to go back over here. 14x squared, and then plus, oops, not minus, oh, I'm a mess, plus 25x plus 6, I believe, yep. Okay, and this is a less than or equal to, so I need to change what I've got over here to the left of my equal sign. So press enter and down, and I this time am going to select the less than choice, so below, and that'll give me what I need. So now I want to look and see clearly. I've got shading on the outside because there's so much shading. You can't see the parabola super well, so I would probably adjust the window a little bit here. It's so squished because I've got too much of the x-axis, more than I need. So I might change this like to go from -7, let's say, to 5, counting by ones, and see if that looks a little bit better. So there I can see a lot more of it, and I could even back it in a little more if I wanted to. But here I can at least, it looks like a smooth curve and it's not looking all choppy. So that looks pretty good. Remember that I have to find my key features, so I'm going to need to find my x-intercepts, my vertex, my y-intercept I don't need the calculator for. So x-intercept, second trace, choice 2. Now this time there are 2 of them. I'm going to find this one first. So it looks like that's at about -1.5. So left bound, I'm just going to enter -2 because last time I used the scroll option. And then -1 is going to be right bound, so I'll type in -1 because I know it's to the right. There are the 2 lines. My x-intercept is between them, so I tell it yes, go ahead and guess. And it looks like what I guessed is actually correct, that my x-intercept is at -1.5, or -3/2. So first x-intercept that I'm going to write down here is -3/2, 0. Then I'm going to go back because I have to find the other. So second trace, choice 2 again. This time, this one looks like it might be at like -1/3-ish. So -1 is definitely left bound. So I'm going to enter that. 0 is definitely right bound. And I'm going to tell it yes, go ahead and guess. And this one does not come out nicely, so we're going to leave that. I can't really, or at least don't know how to write that as a fraction without doing some significant work. So we're just going to do -0.29 because we'll round it to 2 decimal places. So -0.290. Okay, y-intercept, remember we don't need the calculator for. You can confirm it on second graph if you want, but whatever the constant is, that's where your y-intercept is. So now I need to find my vertex. So go back, second trace. My vertex this time is a minimum, so choice 3. Left of the vertex would be -1.5. Right of the vertex would be 0. And there is my vertex. Again, these don't come out nicely, so I'm going to round them. -0.89 and -5.16. So -0.89 and -5.16. So I have graphed it using my calculator. I have found and recorded the intercepts and the vertex. I'm going to graph it now. So 0, 6, 1, 2, 3, 4, 5, 6. I can definitely count by ones on this one. -0.29 would be like right here. -1.5 would be right here. -0.89, -5.6, so almost to -1, and then 1, 2, 3, 4, 5, so just barely past that guy. So there's my vertex. It's super skinny. It is a solid boundary Be careful, try your very best not to make it look pointy, because remember that parabolas have rounded ends. And remember that my graph tells me which way to shade, in this case, the outside. So notice sometimes we have shading inside the parabola, sometimes it's outside. Now, solutions, anything in the shaded region. So I'm going to go with 3, 0 and 5, 5. 3 zeros here, 5 5s up here. They're both in the shaded region. Not solutions. Anything inside the parabola. So -1, 0 would be a good one. And then I'm going to stick with the -1 because it's so skinny, but I'm going to go -1, 4, which would be up here. All right, hopefully that makes sense and you feel pretty good about using your calculator to graph these.